Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be evaluating an infinite radical expression with the imaginary unit, which is I. So I is the number whose square equals -1. Some people also define it as the square root of -1, but you gotta remember -1 has two square roots. If you go with the principal one, you'll probably say it's I. Anyways, we have this infinite sum or infinite radical, and we're going to evaluate this expression. Before I start solving it, I just want to show you the result that I get from Wolfram Alpha. What do you think Wolfram Alpha gives us as the answer? And you'll be surprised, because Wolfram Alpha doesn't understand your query. Too bad. Too bad for the AI. It does not understand every query, of course, but human beings understand this query. Anyways, so what do? We have this infinite square root of I plus the square root of I plus the square root of I expression, and we're going to find the value of this expression. Okay? We're not going to talk much about convergence and divergence here. We're just going to assume this converges to a finite value. Now, what would happen if I was replaced with something like x or 1 or even -1? Would that work? Would we get a complex solution, so on and so forth, right? Great. Anyways, let's take a look. So we can kind of approach it in two ways. We can go ahead and say, hey, suppose we're replacing I with x, and then we consider this infinite sum, or I guess z would be a more appropriate letter here, right? Let's use z. So we set I equal to z. A lot of times you're going to set, variable to a constant if you know the value, but anyways, in this case we're going to use a variable. So how do we find the value of this expression? And let's call that w. Obviously, to be able to solve for z, because that's our goal, right, you would square both sides. And when you do square both sides, right, you would get rid of the outer shell, I mean the square root, and then you would end up with something like this, right? And then notice that the original expression pops up again, right? This is actually the same thing as the original, which we called w. Great. From here, we can kind of get a value for z, which is w squared minus w. Wait a minute. Do we know what w is though, right? We don't. So we're not actually solving for z. I think I messed up when I said that. We are solving for w. Great. That's an important point, because if you were solving for z, that would mean something like this. The square root of z plus the square root of z plus, maybe we could do this in another video, but suppose this is equal to I. Then from here, if you were solving for z, then you could just proceed with the formula, which would be pretty easy. But in this case, we have a more difficult task. Why? Because you have to solve a quadratic equation. How do you solve a quadratic equation? Easy. Quadratic formula. So let's go ahead and consider this. Z will be considered a constant, right? Because we're finding w in terms of z, then I can replace z with I. Make sense? Great. So I'm kind of finding a general formula. So to solve this problem, we're going to write it as w equals -b plus minus the square root of b squared. By the way, b is the coefficient of w, which is -1, so it's going to be 1 plus 4z, and then that's going to be divided by 2. Awesome. So do we know the value of z? Yes. We can go ahead and replace z with I now, right? Because z is equal to I, or I is equal to z. So from here we get w equals 1 plus minus the square root of 1 plus 4i divided by 2. And the million-dollar question is, which of these is the correct answer, right? Is it 1 plus or 1 minus? Yes, that's a really good question. I would probably go with the plus sign, because it seems to be everything seems to be positive, but you can definitely test it out. I'll show you how we can test it out a little bit. But let's just go with one of these, say w. I take the principal value to be the positive one, the plus sign, and I take this to be the answer. But again, this is not in the simplest form, is it? No, it's not. How do we simplify it? We need to find the square root of 1 plus 4i. Do you know what it is? There are two square roots, by the way. So, but it doesn't matter. As long as you, again, go with the plus one, hopefully you'll be fine. But again, we can kind of test it out, right? So how do we find the square root of 1 plus 4i, at least one of the square roots? Because the other one is just going to be the opposite, right? So here's one way to find it. You can set it equal to a plus bi. Yay, that's the name of the channel. And then square both sides. Let's do it. When we do, we get something like this. Let me put this first. So we get a squared plus 2abi plus b squared I squared. But remember, I squared is equal to -1. So this becomes negative b squared, and I can kind of put a squared with b squared. That's going to make up the real part. And then 2ab is the imaginary part. And I have a real part and an imaginary part. Awesome. One-to-one correspondence. So this needs to be equal to 1, right? That's how complex numbers are equal. And this needs to equal 4. Awesome. That gives us a really nice system. A squared minus b squared equals 1. And ab equals 2. I just divided both sides by 2. Okay? How do you solve such a system? It's quadratic. There's a couple different ways to do it. One method is you can go ahead and replace b with 2 over a and then kind of plug it in here. That will give you a solution. Let's try that. A squared minus 4 over a squared equals 1. Obviously, I'm going to replace a squared with c, and then we can back substitute. That's going to give me c minus 4 over c equals 1. Multiply everything by c. We know c does not equal 0. C squared minus 4 equals c. Do you see what I see? Hopefully you do. C squared minus c minus 4 equals 0. And from here, we're going to get two values. And guess what? A and b are kind of interchangeable. I'll show you in a little bit, but let's go ahead and solve for c first. Now to solve for c, we're going to use the quadratic formula, negative b plus minus the square root of b squared, 1 plus, because 1 minus minus, 16, which is 17, square root of 17 divided by 2. Don't worry, this is real. There are two real values, so c sub 1 would be 1 plus root 17 over 2. And c sub 2 would be 1 minus root 17 over 2. Now we got two values, and notice that a squared is equal to c. So these are the values for a squared. But here's the problem. The second number, this value of c, which is supposed to be a squared, is not good because a squared cannot be negative. Remember, a and b are real numbers. When you assume that, okay, suppose the square root of 1 plus 4i is equal to a plus bi, here the assumption, I guess implicitly, whatever, ab is not c, ab are real numbers. Make sense? Okay, they have to be by definition. So I don't think we can use 1 minus root 17. So what are we going to do with that then? Just throw it away and look at this, because this already gives us two values. What? A squared is 1 plus root 17 over 2. And then from here, a is going to be plus minus square root of that number, right? So one of them is going to be positive. The other one is going to be negative. And when you multiply them, that's going to give you 2. So if a is taken to be the positive one, then b is going to be the negative one. Inside, they are the same. They're just opposites. A and b are opposites. So in other words, a plus b, I think, is 0. Is that the case? Anyways, from here, you can basically make up the a plus b. Oh, a plus b is 0, but a squared, ab is equal to 2. Okay, how is that 2? If you multiply them, you're going to get negative the square root of 1 minus 17 over 4. But that's going to be problematic, right? Anyways, I think hopefully you get the idea. I'm kind of confusing myself. But from here, you are basically finding the values that will work and then finding the square root and then plug it in here and you'll find the value of w. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.